NCCER Basic Materials 34104-10 Boilermaker Level 1 4.0 SMAW Electrodes Gary A. Pace PE CWI May 2019. Just putting together another one of these modules for Boilermaker Level 1. This material isn't from the official book. I kind of went to alternative sources and give you the same information. So if the wording doesn't jibe word for word, it's because I'm kind of shadowing what they've got going on, giving you the same information but from different sources. First off, oxygen is not our friend. I know this is kind of counterintuitive because all life is based on oxygen, but in materials joining and welding, oxygen is not our friend. Metals at high temperatures are reactive chemically with the main constituents of air, oxygen and nitrogen. Should the metal in the molten weld pool come in contact with air, porosity, oxides, and nitrides would be formed, which upon solidification of the molten weld pool could destroy the strength properties of the weld joint. So, knowing that oxygen isn't our friend and that we want to avoid atmospheric contamination of the weld pool, we want to keep oxygen from crashing the party. We want to keep oxygen out of our weld pool. This is the basis of welding most materials that you're ever going to run across. You know, I use this as kind of a, I don't know, cheesy one-liner. You know, oxygen is not our friend, but that's a easy way to, think of, atmospheric contamination. We don't want oxygen in our weld pool. So, in knowing this, we got to go forward and think of how we're going to keep oxygen out of the weld pool and nitrogen. Knowing that oxygen is not our friend, it gets back to where does the weld metal come from? So we need to know where weld metal comes from so then we can figure out how to keep the oxygen and other atmospheric contaminants out of our weld puddle. So the welding process we're going to talk about today is shielded metal arc welding, otherwise known as stick. Shielded metal arc welding is basically, and I'm sure somebody's going to blow back on me and tell me I'm wrong or I'm a hillbilly for saying this. But basically, shielded metal arc welding is some powder on the outside of a coat hanger for carbon steel. I don't know what the material tensile strengths of your average coat hanger, carbon steel coat hanger would be, but I'm betting it'd be somewhere in the ball game of what you'd be able to use for welding, your basic farm implements or, garden variety carbon steels. That being said, shielded metal arc welding is a piece of wire with a flux on it. And some things I've read when electric arc welding first started, I've seen some shielded old electrodes that had string wrapped around them. Somebody back in the day figured out if you wrapped string around your electrode and you welded with it, it would burn. Well, in burning, it would chase off the oxygen and the nitrogen. And then some point somebody, and this is all hearsay and anecdotal, I haven't done a bunch of research into it, and then at some point somebody decided, hey, what if we wrap it with newspaper? So they wrapped it with newspaper and it caught on fire and, they were able to keep the, have better luck with their welds, have better outcomes with the welding. Well, and then that progressed into somebody setting up to manufacture, 6010, which is a cellulose-based flux, which is basically wood chips and paper, which when it burns, it kicks off, some gaseous fumes and whatnot, and is able to protect our weld pool from oxygen. So that's where our weld metal comes from. If we took a slice through our shielded metal arc welding electrode, we would have our steel core, which is basically wire, and we'd have a flux. There's a whole bunch of different kinds of fluxes you can put on the outside. But this would be an end view. You've got the flux on the outside and the steel core on the inside. We're going to talk today about shielded metal arc welding electrodes. Stick electrodes is something you might have heard. There's a little bit more to this material than somebody would think. You know, to the average passerby, they just see some guy with a welding hood, some gloves, and doing stick welding. He's just got a chunk of metal and he's making smoke and sparks. Well, there's a whole science to this shielded metal arc welding electrode thing, and we're just going to touch briefly on it. We could do a deep dive into this and go down into the rabbit hole chasing Alice and not come out for a long time. So I'm trying not to get off in the weeds too much, but we're just going to talk about stick welding electrodes a little bit and give you a general idea of some of the information involved with what makes these things go. So the standards specific to the shielded metal arc welding are like AWS 5.1. This is a specification for carbon steel electrodes for shielded metal arc welding. It's a little book of about, I want to say 40 or 50 pages. You can see a picture of what one of these SFAs look like, these specifications for filler metal. And it's just a little book, a little specification that tells you everything that needs to be known about that specific material and how the people that are the manufacturers are going to make it. They have to follow those rules to produce that product and then put that particular product out on the market as, let's say, 7018. So then you have SFA A5.5, which is for low alloy electrodes. It's a little different than 5.1, but it would be a 7018 with some extra alloying elements thrown in there. And 5.4 is for shielded metal arc welding for corrosion resisting chromium, chrome nickel steels. I think that's a fancy way of saying stainless steel. But here's a couple of pictures of some SFAs that I had in my library, and you can see that there's not much to them. There's a lot of information to them, but it's not a very thick 500-page book, these specifications. And they're good sometimes for looking things up. My friend left them to me, so I threw them in my library. So when we want to talk about shielded metal arc welding filler metal electrodes and the nomenclature to describe them, so we've got, this will be the starter, and then we'll get into some more complicated stuff. So the E stands for electrode. That's all it is. Electrode means we're going to run electricity through this filler material to get it to deposit into the weld joint. If we had other designations for like gas tungsten arc welding or gas metal arc welding, you have ER, which is electrode or rod. This isn't a rod. This is strictly electrode. This is a consumable electrode. It is going to be consumed. It is going to run electricity through it. So we've got the E as the first number. The second two numbers, the 70, the 7 and the 0, that's going to tell us our tensile strength. So the 70 indicates 70,000 psi tensile strength. The 2, that third number, the 2, indicates use for welding in flat, groove, or horizontal fillet positions. So we can't use this filler material in all positions. And then the 4, that last digit, tells us which type of flux coating it has. So this would be iron powder titania. E stands for electrode. The first two numbers indicate the tensile strength. The last. So for shielded metal arc welding electrodes for carbon steel, typical values for the first two digits are 60, 70, 80, 90, 100, and 110. Anything generally I see with above a 70, I throw up a red flag and got to ask myself how much preheat there is going to be, or if this thing needs to be post-weld heat treated in any way. So just something to think about. But I was going to say that third one where it says 10718, that's one of the strangest ones I've run across. Worked for had a job years back, and one of our clients had a very specific formula for some welding electrodes that they needed us to use on their stuff. So yeah, there was actually a 10718. I looked at it a few times and was like, what is this stuff? Because you go from 118 to a 11018 to a 12018, and then there's this 10718. So there's a lot of different things you can run into out there in the world. So just a thought. When we're talking about welding positions in that third digit, this is what we're talking about. We're talking about the position in which you're going to make the weld. So you can see in our upper right-hand corner, that would be a 3G weld. We would be welding uphill. We would be going in the vertical direction. It would be like walking over the wall, and we're going to weld up the wall. That would be vertical. Horizontal is if we went to the wall and we went crossways on the wall. I don't have that picture shown. In the bottom left hand, there's a flat piece of plate. That's 1G. That's the flat position. So if we're welding in the flat position, it would just be like pouring water on the floor. It's just put it on the floor, and we're going to weld in that position. That is the flat position. Then we've got a couple others here that are for pipe. So that comes into play when we're picking our filler material, because something like 7024 or 7048 is not going to work on welding these pieces of pipe in these positions, because something like 7024 is for flat and horizontal fillets only. And then the 4 is flat, horizontal, vertical down, or overhead. So you might be able to get something done with the 48 depending on what you had going on. But this is the differences in the filler materials, and you need to be cognizant of it. That's what that third number is the welding position that you can utilize that filler material in. 7024 is not going to run in an overhead position, or it's not going to run vertical up. It's just not. You're going to make a mess, and it's going to be bad. But this is the nomenclature that we use to identify and keep track of filler materials so that you can get the right filler material for the right joint and specific configuration. So when we talk about the electrode coatings, we're really talking about the last digit, the 0, the 1, 2, 3, 4, 5, 6, 8. Two of the most popular or the most common you'll run across in industry if they're welding is the XX10s, which would be like a 6010, which is a high cellulose sodium electrode. When we say cellulose, the coating on that stick welding electrode is basically wood chips and paper. Kind of has a paper smell, a paper burning smell when you're welding with it. That's because you're burning cellulose. It's paper and wood chips. And then we have the low hydrogen electrodes, which you're going to run across, which would be like a 7018 or an 8018 or a 9018. These are low hydrogen electrodes, and they're pretty similar to, I think it's the 15s and the 16s because they're potassium based, but it's made out of, there's no cellulose in the 7018. It's just a mineral powder. You're basically burning dirt. Special fancy kind of dirt, but that's basically what you're burning is a mineral. The flux has a mineral composition, scientific, everything dialed in to give you a really high quality, low hydrogen weld deposit. So here you can see we've got one that's a little bit more complicated. So we've got E8018-B1-H4R. So the E, of course, is a consumable electrode. We're going to run electricity through this to get it to deposit in the weld joint. The 80 indicates 80,000 psi tensile strength. And the 1 indicates use for welding in all positions. The 8 indicates that it's a low hydrogen electrode, flux type. Well, we've got that B1 in there. Well, anytime we get to a situation where we've got a letter and a number in there, that's telling us what kind of extra goodies have been added to the flux and the weld metal. That's telling us that this one's telling us that we've had some chemistry added, some extra elements added, some alloying elements added. That's going to give us 0.5% chrome and then another 0.5% molybdenum. So this would give us some enhanced, mechanical properties down the road that if we just used regular run-of-the-mill 8018, we wouldn't get to. So then the H4 signifies the maximum amount of hydrogen that will be diffused from the rod. And then the R means that the rod is moisture resistant. So you can have different numbers for that H4 or H. There's different numbers that you can have in there. I haven't dealt with them in a while, but I do remember that we used to specifically buy material that had to have a certain hydrogen diffusion quantity. Okay, here's another one. We talked about 7018. Well, in dealing with 7018, at some point you're going to come across E7018-1. This is 7018, but it's kind of 7018, a special 7018. So electrodes designated as E7018-1 have the same usability and weld metal composition as E7018 electrodes, except that the manganese content is set to the high end of the range. They are intended for welds requiring a lower transition temperature than is normally available from 7018 electrodes. So you might be on a job where they only want you to use 7018-1, which is a different animal than 7018 period with no -1. Depending on the specifications, where you're working, what's going on. But anyways, you need to be cognizant of this, that 7018-1 is for the most part 7018, but there's a subtle difference, and if you're on a job where they need a lower transition temperature, this can be a big thing. So I guess the point of this slide is you can't ignore that one. You need to be aware that it exists, and when you're dealing with filler materials, every letter means something, and sometimes they're super important and other times they're not. So you need to just keep an eye on the job requirements and what the specifications are for that specific job and go from there. I'm not going to get off in the weeds too much on weld metal chemistry. We mentioned manganese on the previous slide for E7018-1. So these numbers give us the recipe if we're making a specific filler material. So in red, I've got E7018 there. So it tells us we can have a maximum carbon content of 0.15. We can have manganese of 1.6, and it just goes down: silicon, phosphorus, sulfur, nickel, chrome, moly, etc. Well, on the previous slide, it said 7018-1 has the manganese set at the higher end of the spectrum for this material. So I can make E7018, and I could have the manganese content at, let's say, 0.3. Nobody's going to complain. I'm within my chemistry. I'm good. Well, if we're doing 7018-1, if we're making a batch of that, if we're the manufacturer, we'd probably want to have the manganese up around 1.4, 1.45, 1.5 on the upper end of that, right? It's still 7018. It still falls into the 7018 category, but it's got a higher manganese content, so that means it's E7018-1. And that's the difference. It just gives it a better, I think it gives it better impact strength and where you need a lower transition temperature. Shielded Metal Arc Welding Electrode Designation. So here we've kind of merged our two tables. On the left-hand side, we've got the type of coating and current. And then on the right-hand side, we've got the alloying content of the weld metal deposit. So you can see, once again, we've got an example, E6010, which would be cellulose, all position, DCEP, 60 KSI minimum tensile strength. 7018 would be low hydrogen, all position, AC or DC, electrode positive, 70 KSI, ultimate tensile strength. Well, then we get down to that third one, and we tack on the A1 from the right-hand alloy content of weld metal deposit. And that A1 just says we're going to get 0.5% molybdenum into our weld metal deposit. So you can see there's a whole bunch of different alloying contents. So you can have an E7018 C2, an E7018 B3, an E6010, C3. I don't know if you could do that, but you'd probably go to a 7010 C3. So, and then we've got G down at the bottom, which is, as I'll state again later on, but G is a special recipe. So if we run across one of these filler materials where it's got 8018 C2 or 7018 C3 or something with a designation behind it, it's just telling us that it's a filler material that's got extra alloying elements in it to give it some kind of additional mechanical or corrosion resistant properties. They've added another, like I said, alloying element to help, give it a chemistry that is above and beyond what you could get from the chemistry of the deposited weld metal from the, like a regular 7018. And if you see the G down there, that's special recipe. When we talk about manufacturers' classifications, we're talking about what did they name it? It's like Sprite. It's a lemon lime soda. There's 500 million different variations on Sprite, 7-Up, Slice, whatever the lemon lime cola is, right? Or soda. And everybody's got a different variation of it. And that's kind of what we're talking about with manufacturers' classifications. Hobart's got 4, I went on their website. Hobart's got 4 different variations on 7018. So they throw different things into the fluxes to give it a little better, characteristics for a certain job. Maybe a little more impact strength. I don't know. I didn't dive too deeply into it. But they all fit the bill for 7018, but some have some additional characteristics that might make it a little better to use for certain jobs. And here I showed you 6010. They've got 2 different 6010s listed, Pipe Master Pro 60 and then just regular Hobart 610. I don't know what the difference is between the Pipe Master Pro and just the Hobart 610, but I would assume that it's, like getting a pepperoni pizza, but you just get more pepperoni on it. You know what I mean? It's still a pepperoni pizza, but you paid for double the pepperoni or some specific characteristic. It's still a pizza, but a pepperoni pizza, but it's got a little something extra in it. Here we've got a list of the different 7018 variations made by Lincoln Electric. They've got, some that are good for nuclear power plant, power generation. Others are general fabrication. Different variations. I don't know what the differences are. If this really interests you, you can dig in and figure out the exact specifics. And I'm sure there's a reason they do this. Some of it's nuclear. You're going to need a higher quality. Everything's just got to be exactly perfect in regards to what you got going on. And then others, general fabrication. It's still a high quality product, but it might not meet the standards of nuclear construction. So there's different variations for different manufacturers. So if you're on a job and there's, Lincoln 7018, there's 3 different variations. You need to make sure that you're getting the right variation for whatever you're working on. A lot of times things are by heat and lot number, very specific. But anyways, you need to be cognizant of this. Okay, we're going to talk about electrode sizes. When we talk about diameter, we're talking about the diameter of the metal core of the piece of wire that is the electrode. We don't count the diameter of the flux. Different filler materials are going to have different flux diameters. The fluxes are way different between E7024 and E6010. E6010's got a really small flux on it. It doesn't have any iron powder in it, so it doesn't have near the diameter. So we measure diameters by the core wire diameter. So the one that I'm used to dealing with, or that I've got pictures on the next slide, would be 1/8 inch diameter in 14-inch lengths. But you can get bigger filler materials. I've welded with E7018 that was a 1/4 inch diameter, which is huge. You can really lay down a really big weld bead, and it's pretty hot, and you can go like hell. Get some high deposition rates. So when they sell you that, you have an 18-inch long electrode as opposed to a 14-inch long electrode. And from the looks of it, you can get up to a 28-inch long electrode if you got 1/4 inch 7024 or something. You could get a really, really big electrode. So I think a lot of these sizes go back to the 60s and 70s, when there was a lot of fabrication going on with stick welding before, gas metal arc welding, MIG welding, and flux core arc welding really became a much more commonplace. But anyways, these are the electrode sizes. You're talking about the diameter. So if somebody tells you, hey, go grab me some 1/8 inch 7018, okay, now you know what they're talking about. It's the diameter of the steel core that's going to tell you the size of it. And they have the sizes listed on the packaging too. Here's some electrodes that are 1/8 inch in diameter. There's 3 different ones, and they have markedly different fluxes. We've got E6010, which is an electrode that is covered with wood chips and paper, more or less. It's out of cellulose flux. There's no iron powder in it. So it's a pretty small diameter electrode in regards to the flux. You can see the one on the top, E7024, there's a whole bunch of iron powder in there. 20, 30, 40, 50% of that material's flux is iron powder. But that helps achieve a higher deposition rate when we're welding in a flat position with it, which is the position we utilize it in. So we're looking for deposition rates. It's got a different flux. Then we got 7018 in the middle. But the wire core on all 3 of these wires is 1/8 inch in diameter. So it's just 1/8 inch diameter. We could get 532, 332, 1/4 inch. Depending on what your application is, what you're welding, you could use different sizes of filler material. And these ones are all 14 inches long. That's a pretty standard size for most welding electrodes. You can get them bigger for different situations. There's some places, if you needed, electrodes, there's certain places that make electrodes, and it's like going to a specialty pizza place. They'll cook whatever you want if you got enough money. You can go in and tell them, I need X amount of pounds of this filler material, and they'll make it. So just a couple of tidbits for you in regards to filler metal electrode sizes. Okay, I know it gets tedious. I include one of these in about every other presentation I do, but I guess I just want to spread the wealth. Acknowledgments. I poach a lot of this material from the Nuclear Regulatory Commission Introduction to Welding Technology and Code courses. ML12157A587. It's a good starting point. Can teach the Canadian deuterium uranium people. HTTPS, I'm not going to read that web page. You guys can figure it out, the can do stuff. The U.S. Army's also got a pretty good, it's old, but it covers a lot of material. TM 9-237 Welding Theory and Application is a good place to find some high quality welding information. None of it's changed over the last 50 years, but anyways, that's why I always include this, is because there might be somebody out there that's looking for some free material, doesn't want to pay for a book, and you want some good high quality welding material. This is it. Questions, comments, concerns? Maybe you think there's another subject in regards to welding that I should touch base on. My name is Gary Pace. I'm a PE CWI out of Katy, Texas. You need to track me down. You guys know how to find me. Take care. GP out.